Hello friends, welcome back to our channel. So today we'll see one more concept in compiler design, that is a backpatching. So actually this process of a backpatching means in order to generate the three address code, particularly for conditional statements or iterative statements, so we require some unconditional and conditional jumps. So that means the control should go to some other address. So how to know that particular address? So for this process, the backpatching comes here. So first it will generate a code with some placeholders, and once the code was completely generated, then the appropriate and a correct address will be given to the unconditional or a conditional jumps. So this process is called as a backpatching. So in today's session, we'll see the backpatching and the translation rules for this backpatching, and then in our next session, we'll see an example for this backpatching. So let's start the session. So backpatching. So it is a technique in a compiler to generate code with placeholders. That means it will leave some blanks to give correct address in jumping instructions. Jumps that may be both conditional and unconditional. So here let us take an example. So if a greater than b, some x equal to 0, else y is equal to 0, right? So let us take this example. And what is the three address code we have written? So if a greater than b, if it is true, we are simply saying here go to some statement, some label. So here what happens means in backpatching, it will leave some placeholder in order to fill that with a correct address later. Okay, later, this is important. And if it is false, go to another. If a, yeah, see, let us write here the address is 100 and this is 101. Okay, address 101, and it will be x equal to 0, 102, and go to dash, and this is 103, and 104 is y equal to 0 and 105. Okay, so these are the steps. Actually we have studied the representation of three address code, right? Representation of three address code in quadruples, triples, and indirect triples. So whatever the lines we are writing here, everything will be stored in the that particular table. So among the three, we have studied that quadruples will be the best suitable for generating the three address code, right? So using some temporary variables. Okay, so every line will be there in the quadruples, so it will be retrieving one line after another. So here you can see if a greater than b, if a greater than b, what should be executed? X equal to 0 should be executed. So where we have written x equal to 0 here. So the address of this one is 102. So you can fill this one later. And if it is false, it should move on with the y equal to 0. Okay, it should move on with y is equal to 0. So y is equal to 0 address is 104. So it will fill 104. And after completion of this one 102, x equal to 0, it should not execute these statements, it should skip this one. So immediately it should go to 105, so it will be 105. Okay, so like this the three address code will be generated first, leaving the place to give the correct address of a jumps later. Okay, so this is called as a backpatching. So already previous sessions we have seen, we have experienced a lot of confusion So regarding the addresses, we have given some labels L1, L2, L3 and so on. So while writing the instruction itself, it seems it will be difficult to write the label unless you know the address. So this is a solution for that particular thing. So here the code is very simple, so we can simply write it. But when compared to the large and complex expressions, Boolean expressions, so that will be different. There will be more number of conditional jumps and unconditional jumps. So that will be very difficult until you know the addresses of that particular statements. Okay, so this is called a backpatching. And before applying this backpatching into the code, so we will see there will be a two list should be uh, maintained. So one is a true list, another one is a false list. See, this backpatching will also be suitable for uh, the short circuit evaluation, that means a complex instructions or complex expressions. So true list will be maintaining all the list of instructions, to jump if the condition is true. And this is a list of instructions. This is a list of instructions to jump if the condition is false. So for every expression, it will be maintaining two lists. One is a true list and false list. So this will be represented as TL and this will be represented as FL. TL and FL. For every Boolean expression, there will be TL and FL. So which statements should be executed? Which statement should be, I mean, when the condition becomes true, and which statement should be executed when the condition becomes false. And apart from these two lists, there will be three more functions. Mainly, it will be used. So functions, one is a make list. Make list is a function, okay, which will create a list, and merge function, merge, so B1 and B2, so two conditions, so it will combines the two list. And next one is a backpatch, so B and target. So what should be executed if B? Okay, so locate correct address. So these three functions are very important in the concept of backpatching. Now by using these three functions, let us see the translation rules. Okay, so before applying this to our example, so you need to know the translation rules. So the translation rules, let us see. So first one, B implies B1 ampersand MB2. MB2. So M is nothing but a instruction that to be executed before B2. Okay, starting of the instruction. So let us take it as a starting of the instruction. So we know the short circuit evaluation. For example, B1 is a one conditional expression and B2 is another conditional expression. So if B1 is true, so this is an end operation. End operation means if any one of the input, if any one of the output is false, the result will be false. So if B1 is true, then only the B2 will be started. Okay, that is a M. B2 will be started. And if B1 is false, what happens? Whole expression will be false. Whole expression is false. Whole expression will be false. So here you can see backpatch, the backpatch function. Okay, backpatch function for this particular thing. So if b1 dot true list, that means b1 dot true list means the true list contains b1, that means the boolean expression is true. So when b1 is true, then it start m, that means m is a starting address of b2, for example. Let us consider, so m will be the thing. And see, for every expression there will be two list, just now we have seen. So b dot true list and b dot false list, true list and false list. So when this b dot true list will become true, true list, this is a true, when becomes this b becomes true if b2 is true. So if b2 is in true list, automatically b1 will be true, because until and unless b1 is true, b2 will not be get executed. So if b1 is false, b2 will not be computed. Okay, automatically that comes end. So whenever, I mean, when the b becomes true, the boolean expression becomes true whenever b2 becomes true. Okay, and whenever b false, when the b becomes false, the boolean expression becomes false, either b1 is false or b2 is false. So it will be merge function, merge function. If b1 is in false list, b2 is in false list, anything, if anyone is in the false list, automatically the result will be false. Whenever the b2 is true, b2 is true, immediately the b becomes true. Okay, so this is the first thing, which is a end operation, end operation. And the second one, so you need to remember these three things. Okay, so these things will be useful while drawing the annotated parse tree for any example. Okay, so just remember this one. And the second rule, b1 or mb2, the same thing. Okay, previously we have seen the end operation, and now we are seeing the end or operation. Or operation means if b1 is false, b1 is false, then b2 will be started, because if any one of the input is true, automatically the result will becomes true. So if b1 becomes false, it have to check whether b2 is true or not. So if b1 is false, b2 will be started. If b1 is true, you need not compute the b2, because b1 is already true, the result will be true. So b1 is false, sorry, here b1 is true, the whole expression is will be true. Hope you understood. And here backpatch, b1 is in a false list, then m will be started. And when the b dot false list comes, if b2 is in a false list, and when it will be true, either so merge, either b1 is in true list or b2 is in true list. Hope you understood. So if any one of the thing is in a true list, automatically that will be true. If b2 is false, so when the b2 is computed, if b1 is false, then only b2 will be computed. So whenever b2 becomes in a false list, automatically b becomes a false, the result will be false. So this is the second one, translation rule. And the third one, b tends to not b1, not. So obviously if when the b becomes a true, if b1 becomes false list, because it's a not. If it is true, the result will be false. If it is false, the result will be true. Similarly, when it will be false list, whenever it is in true list, whenever the b1 is in true list, the result will be false. And the next one, b tends to b1. So when this is similar to assignment, okay, when the b becomes in a true list, if b1 is also in true list, automatically the result is b true list. When it will be in false list, whenever the B1 is in false list, automatically that will be. So like this, there will be a lot of translation rules. Okay, there are a lot of translations rules, but these are very important for any Boolean expression. So we are talking about the Boolean expressions. So Boolean expressions means this one, right? So in our previous session also we have seen the short circuit evaluation just for logical AND and logical OR. That becomes more complex. Okay, if the condition is having the logical operations, that expression becomes complex to write the code. So for that purpose we are doing this translation rules. These are the translation rules. So before applying the backpatching or before going to the examples, you need to learn all these translation rules. Okay, so these rules will be applied for generating the annotated parse tree of any kind of example. So one thing remember, so in our last session we have seen the 3 address code will be represented in a quadruples for code optimization. So every address will be stored in a quadruples. So one after another it will be uh, I mean uh, it will be evaluated. Okay, so I'll stop here. Just remember all these rules, translation rules and functions. So in our next session we'll see one example and we will generate the code, and later we will give the addresses, and later with the help of all these translation rules we will draw the annotated parse tree. Okay, so if you really enjoyed the session, like my session, and if you are having any queries regarding this one, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.